Hello, I'm Dr. Sam Wasser. I'm the director of the Center for Conservation Biology at the University of Washington. A big area of our work has to do with the illegal ivory trade and using forensic science to combat that trade. The ivory tends to be shipped in large containers and moved on ships from Africa to Southeast Asia and elsewhere. One of the challenges about this trade and the way that the ivory is moved is the fact that there is 1 billion shipping containers being moved around the world each year right now. And even in the most sophisticated countries, they can inspect about 2% of the shipments that come into their ports. Traffickers are very aware of this. All they have to do is get their containers past customs into transit, and they've pretty much got it made because there's about a 2% chance that the containers will be inspected. One of our biggest challenges is to figure out where the majority of ivory is being poached in Africa. We call those poaching hotspots. The other thing that we try to do is to figure out how many criminals are actually involved in exporting this ivory out of Africa. We use forensic genetics to do this, and essentially we take advantage of the fact that populations of elephants separated over space and time become genetically more distinct, and we can use DNA to determine differences between those populations. We did this by creating a DNA reference map of elephants across Africa using DNA extracted from dung samples. We then developed ways to get DNA out of ivory, and by taking the same 16 genetic markers from ivory that we acquire from the dung samples, we were able to match the DNA, the genotypes of these tusks to the reference map to figure out where most poaching was taking place. We're very surprised to find that about 78% of all ivory was coming out of East Africa, and really an area concentrated from northern Mozambique through Tanzania into southern Kenya. This was an important finding because at the time, people thought that these large shipments were essentially being created from traffickers cherry picking from samples across Africa to build up these large consignments to ship out. But we showed that instead they were poaching the same areas over and over again to get these big packages of ivory to ship. We also showed that most of this ivory was being shipped out of a different country from where it was actually being poached. And that too was a very important part of this puzzle. One of the most optimistic things that happened out of this work is that over a period of decades and continually reporting this work in the press, going to CITES conventions and talking about where the poaching is most concentrated in Africa, eventually in the last year or year and a half, we have seen for the first time a decline in poaching across East Africa. That is a very important breakthrough and something to be very optimistic about. Of course, we were not solely responsible for this change, but we had a very important role that we played in this. While it was an important breakthrough to discover these poaching hotspots, poachers still prove very, very hard to catch. And that's partly because of what makes a poaching hotspot. A hotspot is a large area that has a lot of elephants that are able to essentially provide ivory for repeatedly over many, many years. These poachers live in these areas and they know them very, very well, and so finding them in these large areas can be quite a challenge. Not only that, when you do find them, the poachers typically have only as much ivory as they can carry, and so if you get an arrest, you still didn't get very many tusks. 10 tusks, 20 tusks would be a very, very large arrest. But if you think about these seizures that are being made, that are being exported out of Africa, those have sometimes 1,000 or 2,000 tusks in there. So really, getting the poachers is an important breakthrough, although they're hard to find. But really the big breakthrough is getting these big traffickers, these big transnational criminals that are moving large volumes out of Africa and doing so out of a different country from where the poaching is actually occurring. So middlemen were coming and buying this ivory from poachers and essentially consolidating up the crime chain to the place where the major exporters were operating. One of the things that we learned that in these ports there tended to be one or at most two major exporters or transnational criminals moving this ivory out of Africa. And essentially that whole pyramid of ivory transport from the poachers up through the middlemen to the place of export was really being driven by a small number of major traffickers. And what that means is that when these two tusks get separated, even though they're separated as they move up this crime chain, they still tend to end up with the same transnational criminal in the end. It's just that they arrive at the place of export at different times and they get shipped out in separate shipments. So by genetically matching tusks between shipments, that is what allowed us to connect these individual traffickers to multiple shipments and to see just how big these traffickers are. We found that whenever you had two tusks in separate shipments, that those shipments were always being moved out of the same port, close in time, and the ivory, if you look at where the ivory came from in those two shipments, it was always coming from the same location. That reinforced the idea that it was the same trafficker involved in moving this ivory out of Africa. The genetic evidence that we obtained linking an individual trafficker to multiple shipments led to the conviction of one of the largest ivory traffickers in Africa. The Kenya government convicted him to 20 years in prison. However, 2 years into his sentence, he got acquitted. One of the problems that occurred was he was tried for only one seizure out of the 11 or more that he was linked to. Now, there was a lot of forensic evidence that linked that single seizure to all the others, but the case that he was tried for actually did not have a genetic match to any of the other 11 seizures that were linked by genetic matches. It made that case very vulnerable, and what happened was that there were a lot of irregularities in the case, and eventually those were used to acquit him. What we did was we started to rely on a technique called familial matching. Familial matching relies on the fact that close female relatives stay in the same family group. And so if you can match tusks from the same family members, close family members, parent, offspring, full sibs, and half sibs found in separate seizures, it essentially implies that those seizures came from ivory shipped out of the same family group. And given how we know ivory is moving up the crime chain, it's very likely that that connects the same transnational criminal to these multiple shipments. The majority of familial matches we were able to make linked that single ivory trafficker to virtually all 11 of the other shipments that we had connected him to through other forensic evidence. It also had many matches to the single seizure he was tried for to those 11 other shipments. Bringing financial crime investigations into the prosecution of these cases is a very powerful tool because corruption often undermines these cases. By connecting many different seizures together through the genetic linkages and tying that to financial crimes essentially creates a situation where the trial becomes much less vulnerable to the impacts of corruption. We realized that all of these familial matchings was essentially creating a roadmap for U.S. Homeland Security investigations to pursue in their financial crime investigations into these criminal entities. And in this case, because we had linked this trafficker to so many different other seizures, we knew where the ivory was shipped out of, we knew what routes it was taken, and essentially it provided not only the information on one single seizure that could be tracked financially, but 11 that were all interconnected. And this provided a rich body of evidence for Homeland Security to be able to connect the dots in their financial crime investigations. The power of this is that financial crimes are considered major crimes. And that means that if we are able to build these cases by taking all of the connections that we were able to make through our genetic evidence and linking that to these financial crimes, we essentially will create a situation that is much more immune from the corruption that allowed this previous criminal to get off at the first place. The complementary tools that we have developed give us great optimism that we have developed a way to fight the complexities of transnational organized crime and the illegal wildlife trade. This is a powerful way forward, and we hope that over time this is going to make a big difference in how we prosecute these criminals. Thank you.